one makes maybe one discovery in one's life. Discovery is something that changes the perspective, makes it very different what you knew the night before from what you do now, from what you know now. So, if someone comes and tells me we have detected forms of life, that is biological activity, not we haven't seen little green men or something, biological activities in the atmosphere of other planets, that is a showstopper, that is a discovery. It's like when Galileo saw something going around something else that wasn't us. That changed the paradigm completely.
It's part of our job to be very skeptic. But once the discovery stands all the tests and all the challenges we throw at them, it's this sense of awe at something that finally is established, and it's a new realm or a new kind of object or a new theory to interpret what we're seeing. So it's a great and very rewarding process.
The Giant Magellan Telescope is the next big step forward in developing tools to address some of the forefront questions in the physical sciences. And I think it's exciting that there have been tremendous developments in astronomy, from the prevalence of planets around stars other than our own, learning surprising things about the nature of the universe that we inhabit and its future fate. And astronomy is in many ways a discovery-driven science, and advancing the next set of tools to empower people to really look hard on behalf of all of mankind at these really critical questions. I think the GMT is a central element in that enterprise.
So I think that the most amazing thing about astronomy and the astronomical enterprise in general has to do with the idea that we can actually study our origins in the broadest terms. The origin of the galaxy, the origin of the sun, the origin of the earth, how are planets formed, how are galaxies formed, how does matter in the universe comes together to produce what we call, a home, what we call a planet around a star in a galaxy that's, filled with chemical elements that are produced in the interiors of stars that eventually give rise to life. So the astronomical discoveries and the pursuit of the astronomical enterprise, it's really about understanding our own origins, all the little steps and bottlenecks that we had to go throughout 13.7 billion years of cosmic history. So we end up here right now talking to each other. And I think that idea is fascinating. The fact that we can study and understand, these processes and put together a picture of our own origin throughout the whole history of the universe. And the GMT is going to be a key player in advancing our understanding of these origins of the different things that had to happen so we could end up being here.
The GMT is going to be one of the three really big telescopes on this Earth. And these are the mega telescopes of the 21st century.
One of the most exciting things that the GMT will be able to do has to do with the fact that it has a superb spatial resolution. It's going to have a spatial resolution that is 10 times better than the spatial resolution that we currently can achieve with, for example, the Hubble Space Telescope. And that will allow us to map the inner workings of galaxies out to enormous distances, way beyond what we can do today, and really understand the internal physical processes that are driving galaxy evolution throughout, long periods over cosmic time.
What we want to reach in the end is we want to try to find terrestrial planets and study their atmospheres. And GMT, the upcoming big eyes, will allow us to cut all these edges of the current technological limitation and hopefully bring us closer to this answer. But other than that, GMT is going to offer a wide range of scientists that the scientists and researchers at the CFA would be interested in, for example, to study the star, how they were born or how they die, or you can also study the galaxies, about their evolution, how they grow, and especially another important question in astrophysics is the origin of the universe.
I'm personally involved in the technology development most significantly right now, but I am super excited about what that technology is going to enable, particularly in the area of exoplanet discoveries, what we're going to learn about as we are able to probe smaller planets and closer in planets to stars than we currently are able to.
The idea that we might be able to collaborate with Chilean astronomers and people at Harvard working and having access to different suites of instruments that are available in Chile and expertise that is available in Chile and at Harvard is really important for getting the most out of GMT in the future.
The GMT is broadly important to all the different areas of astrophysics that we do here at CFA. Partly is what I think of as standalone things that you do purely with the GMT and also synergistically with the other sort of science we do here. We're heavily involved in the Atacama ALMA facility, which does a lot of cosmology, star formation. But my particular enthusiasm is for the study of exoplanets. And we put a lot of effort, a number of my colleagues, prominently Mercedes Lopez Morales, and other people here at CFA, not saying so myself, have worked very hard to sort of quantify whether it's possible or not to do a biomarker search, a molecular oxygen search in exoplanet atmospheres for exoplanets that are fairly close, orbiting stars that are fairly close to the Earth. And it seems that we've really got a fighting chance of making that discovery.
Harvard, University of Harvard, and the Smithsonian Institution are both founding members of this telescope, and will have a sizable participation. And having access to a telescope like this opens a completely new world, not only for CFA astronomers, but for all the potential users of these telescopes.
Harvard is playing a key role at developing these instruments. Is playing a key role at developing the project overall and the scientific cases for that will be pursued with the Giant Magellan Telescope. And currently at Las Campanas Observatory, Harvard is already a partner in our existing facilities. The Magellan telescopes, the smaller, the twin brothers of the GMT that came a few decades before them, before the GMT. And so we receive Harvard astronomers at Las Campanas Observatory in Chile all the time to conduct the research. So it's, as I say, Harvard is a key player in this project.
And for Chile, this is also fantastic and a fantastic opportunity to create collaborations. We have access to the telescope at Chilean universities. So I'm definitely interested in that. And I have collaborators at CFA, so I'm happy that I think we'll be able to generate new collaborations. Also for students, I think, if I'm correct, I think you, as part of your program, you have, for example, internships that you can send students from there to come here. So that will create a lot of new collaborations to study different areas. In particular, for me, planet formation. I think that's going to be something completely new that we don't have the ability to study right now, and it's gonna open a lot of doors and discoveries that we cannot even imagine right now, I think. So yeah, it's gonna be great.
The CFA was a very special place, again, as I was doing my grad school search to do my PhD. It was one of these special places in which we had astronomers in the lab experimenting, actively thinking about specifically not just how to characterize these planets, but how to characterize one of the most important biomarkers or signatures of life in the atmospheres of these planets. And that is, of course, drum roll, oxygen. So oxygen is this very special molecule. It makes it is incredibly difficult to detect. We can only do it from the ground, so we cannot do it with, for example, a next generation space-based telescope such as JWST. But we have this special opportunity at the Harvard Smithsonian Center for Astrophysics to actually build the GMT, then build an instrument that is going to be called FIOS, and actually with that instrument FIOS go about detecting oxygen. So that is one of the very special ways in which the CFA is interacting with GMT, is actually not just in the construction of the observatory itself, but developing technology so that we can use this giant light bucket to focus a bunch of light into this very special next generation instrument to go about detecting this molecule that is going to, again, get us closer to answering that question of whether those Earth-like planets in our vicinity, any of them, have oxygen and therefore may have biogenesis occurring in their surfaces and therefore may be amenable to life as we know it on Earth. I think about women in astronomy at the CFA, such as Cecilia Payne-Gaposchkin, who, if you read their biographies, if you read their autobiographies, you can see how they carried their identities very intentionally with them every day of their lives as they did astronomy. And the way I see that with Cecilia Payne-Gaposchkin, who, by the way, is the woman and the scientist that we owe the understanding that the composition of the universe is dominated by hydrogen and helium. The way I see her doing that is I see her carrying her feminine identity and persevering through all of the barriers that were imposed on her at the time, as she tried really to do her science and make people see her perspective on the composition of the universe. But I also see her in how painstakingly detailed she was about analyzing all of these information of stars that, by the way, other women had collected at the CFA in order to answer this question, in order to basically catalog as many stars in the universe as possible, and then put all that information together to start learning about the universe. And so when I think about the ways in which I bring my Latin American womanhood identity into the table every single day of my life, I think about Cecilia Payne. And that is why it's so special to, I guess in my second year of grad school is when I started being able to come into the CFA every day, come into the lobby of the CFA and see this gigantic portrait of her in the lobby and be reminded that, number one, my womanhood, my Latin American identity have a place at the CFA. And number two, one of the most important astronomers of all time was also a woman who carried that identity with her presently in every single thing she did as an astronomer and also, of course, as a human being.
Chile is like one of the places that everyone talks about.
We expect to have first light toward the end of this decade. And when that happens in Chile, assuming that the European is also being commissioned, that implies that the 70% of the total astronomical capability of the world will be in Chile, which is quite staggering.
The Atacama Desert in the north of Chile is probably the best place on Earth to do astronomical observations. The reason is that, the Atacama Desert has this extremely unique combination of geographical and atmospheric conditions, where you have high mountains, you have the Andes mountain range and the cold, Humboldt Current on the Pacific Ocean, which basically means that you have a place where there's almost no humidity in the air. Then in sites like Las Campanas Observatory, we have, of the order of 300 clear nights a year, which is really, it increases the amount of time that you can use this facility. And also the quality of the images that you can get because of how stable the atmosphere is at Las Campanas Observatory is extremely, good. It's one of the best observatories in the world in terms of image quality. So when you have a telescope like the GMT, the capabilities of the telescopes are one thing, but where you put this telescope, really can make an enormous difference in terms of how deep you can go, how faint objects you can detect, and the quality of the data that you're gonna get with this facility.
It is also very important to observe continuously. So you want to know how the system changed through time, and sometimes you have to come back and repeat the observation in, say, a few days or a few months or a few years. And in that particular time, you would need like the perfect condition of the sky. And Chile will give that perfect opportunity for you.
For Chile, it's fantastic to be able to have access to this fantastic instrument, especially since given the atmospherical conditions and the observing conditions in the north of Chile, we can combine this instrument with other amazing instruments for looking into the universe, like the Vera Rubin Observatory, meaning we will have GMT to follow things that change in the sky right away. We'll have the best transient finder tool right next to GMT. We can combine it with ALMA observations, the best radio telescope in the world. And GMT is also right next to other great facilities that will make its science output so much better.
I believe that it could become one of the important center point of contact where Harvard and Latin America can connect, especially between the researchers and local community. And in my opinion, outreach is also important to gain the support from the local community to understand and get them interested in what we do, in particular in Chilean community, which has a fast growing astronomical research, scientists and engineers. So we should also encourage more of this kind of collaboration between Harvard and Chilean Astronomical Society.
With the GMT, we really have a very special opportunity to reflect on the people who are sitting at the table asking these questions that have accompanied humanity for so long, such as the question of whether there is life or not elsewhere in the universe. So we can really go back to thinking about who's sitting at that table and specifically make sure that, because it's a question that belongs to all of humanity is represented in the group of astronomers going after answering these questions. And I think that having an observatory such as powerful as the GMT in a Latin American country as beautiful and culturally rich as Chile is going to actually facilitate that self-reflection and make it more likely that we have a diverse community going after answering this absolutely fantastic and mesmerizing question.
We have a solid network of infrastructure in terms of communications, fiber optics, roads, accessibility to the sites, etc., which is really great, and it's important in terms of handling these operations in these very remote locations, and also the country. It's a place that has a level of political stability and development that allows for a very efficient operation of a high-tech, large scientific facility. So that's why the site that was chosen for the GMT it really provides enormous advantage to the project. And this is something that Chile and the Chilean government and the Chilean people really, have in their minds as something that it's important for the country. Astronomy has become an essential part of the image of the country, and the protection of these sites is becoming more and more relevant, especially in terms of protecting these sites against light pollution. So, for example, the Chilean government has imposed a series of regulations to the illumination of cities and industries in areas that are near astronomical facilities, in order to make sure that we can take advantage of this beautiful natural laboratory, this window to the universe that we have in the Atacama Desert for decades to come.
Well, the GMT is really, we expect it's going to be a breakthrough. Astronomy historically has advanced through breakthroughs enabled by larger telescopes or new technologies, say more sensitive detectors. So as the GMT arrives with a greatly increased size in comparison with existing telescopes, it opens new windows into the universe. And as such, it will allow for us to peer deeper, faster into the universe. And if history is any guide to what will happen, that will lead to many breakthroughs.
We're also going to be able to push the envelope enormously in terms of observing the most distant objects in the universe, the first galaxies that are born, and we're going to be able to observe them as they evolve in the very early epochs of the universe, in the first, let's say, 5% of the history of the universe. Also, the GMT is going to be able to characterize planets, extrasolar planets, about other stars in the Milky Way with exquisite precision, a precision that should be, high enough that would allow us to detect the presence of Earth-sized planets orbiting around solar-type stars, which is a part of the parameter space in the search of extrasolar planets that today it's beyond the reach of any existing instrumentation.
Well, it'll be the next big leap forward in technology for people doing optical and infrared astronomy. So it should open up new areas of research. We already have ideas about what questions we'd like to answer, search for planets around stars, search for life on those planets, chemical signatures of life, including oxygen on those in the atmospheres of those planets. And so there's a lot of exciting plans being formulated, but even more exciting will be the questions we haven't even thought about asking yet, and that will come upon it in the years ahead as we have these new tools available to us.
We know it's going to happen, but perhaps the most exciting, it's that it opens new realms. And if you look back, very often the most striking discoveries of these new facilities were not foreseen.
I'm just excited to see what it's going to discover. I mean, there are lines of research that, they developed the telescope to study planet formation in particular, but when you have a new telescope, you never know what you're going to find.
Are we alone in the universe? Are we going to be able to find something similar to Earth? And if we find the Earth-like planet, whether they are habitable or not.
Being able to observe extremely faint objects opens new worlds. So I think there is a very bright future for astronomy in the first 2 decades or 3 decades of this century. And I encourage people to follow their nose, and if you have an idea, pursue it, work hard, and think of the enjoyment it's going to be when you make either a discovery or a pretty interesting finding.
GMT is really a brand new window into a place where nobody has really looked before, by having one of the largest collecting areas in history and being placed in probably the best place in the world for astronomy from the ground. It will allow us to study how the very first stars formed in the earliest galaxies, all the way through our nearby neighborhood, where we can basically take a look at the nearby stars and the nearest planets and see and look for evidence of life. And maybe, if we're not that lucky, to compare how nearby planets look with respect to how things look in our very close neighborhood. And again, put our own solar system formation history in context. So it will really be a game changer. And anyone that has access to data coming from GMT will be lucky to be able to look at things with brand new eyeglasses for the first time.
The GMT itself will be an enduring flagship for astronomy, astrophysics, physical sciences, and science in general. And we will use it in ways that we can't possibly imagine today. I think that, you know, getting to the threshold of turning the GMT on, learning how to use it, exploring the possibilities, the scientific data that comes out of the GMT will pose new questions we don't dream of today.
I think it's sobering in the multiple challenges that we face across the globe right now, between pandemics, economic challenges, social strife, to think hard about what our priorities are as a civilization. And I'd like to think that astronomers act as ambassadors for all of mankind so that we can learn more about our place in the universe, learn more about coming with a humble perspective to the earth that we inhabit. And I hope very much that we can find the opportunity, the passion, and the commitment to carry through with the investments on resources like the GMT to allow that important work to continue.